All right, let's take a look at today's lesson. We're going to kind of review on absolute value equations. So the absolute value of a number x, it's basically referring to the distance the number is from 0. So for example, if we looked at, say, -3. Let's say we were doing the absolute value of -3. We can see that the distance away from 0, regardless of whether you go right or left, is 3. So the absolute value of -3 is 3. So that's basically what we're looking at. Now, of course, it's going to get a little bit trickier where we're going to solve some equations that have to do with absolute value. The first few basically just have a variable inside the absolute value symbols, just inside there. Those are a little bit easier than the ones that have variables both inside and out, but we'll look at both types. So on our first one, we need to remember this scenario up here. So if this, whatever this quantity is in here, is equal to a 12, this quantity could turn out to be a 12, or it could turn out to be a -12. Right? Those would give us the exact same value once we absolute valued it. So we're going to have two equations to solve when we have absolute values. So let's do that. Let's just solve both these equations. So we move the 8 over, we get a 4, we move the 8 over again, and we get a -20. So the checking your solution thing, pretty important when we have variables outside the absolute value. These should be just fine, but let's just practice. Let's just do our check. And these checks can be done in your head. You don't have to write them out. You can just check them in your head. I'm going to write them out just so that we, have a reference. So if I plug in a 4 here, we see that the absolute value of 12, is 12, and this one checks. Okay, great. So let's do the other one. So we'll plug in a -20, and we have the absolute value of -12, which is, 12. And so both of those check out. Okay, great. So let's take a look at our next example. This example, really, there's a lot of stuff going around the absolute value. What we need to recognize is that we must isolate the absolute value before breaking this into two equations. Okay, so we got to do that first. All right, so let's see. We need to move the 5 over. So we have, let's see, add 5 to both sides. That gives us a 9. We would divide by the 3. Again, we're trying to isolate the absolute value bars. So 9 divided by 3 is 3. Okay, so now we're basically where we were at the beginning of the first example. We're just going to do our two different possibilities. I know that 2x minus 3 could be 3. I also know that 2x minus 3 could be a -3. And so then we're going to work both of those out. So I'm going to add 3. Gives me 6, so x could be 3. Then I add 3 over here, or x could be 0. Those are our two options. Where we can just check it, physically check it, or check it, thinking about it, like just plug it in our head. And I can tell you that both of these work. X can be 3 or 0. Okay, you can write it like that. Another way to write it would be in set notation, where our set would be the set of 0 and 3. Either one of those is fine. All right, let's go on to the next page. Now here we're going to encounter some absolute value equations that are a little bit more difficult because they have variables on the inside and the outside of the absolute value. Now, let me just note here, we talked about setting these absolute value equations equal to, the 12 or the negative 12. Right here, the 12 or the negative 12, or, the 3 or the negative 3. So that kind of makes sense. It's a little bit strange when there's a variable out there, but the concept is the same. What we're going to do is we're going to set this, our first option is to set it equal to what it's, exactly equal to. We're removing the absolute value bars. The other option would be to set this equal to the opposite of the other side. Now there are other ways to think about it, but this is the method that I prefer, just because, we're trying to do the same thing. At the top, when we were working with just numbers, we set it equal to the positive value or the negative value. And so I'm just trying to be consistent with that. So we're going to set it equal to exactly what it is, or opposite of exactly what it is. Okay, so now let's work through, let's solve that. So in the first instance, I'm going to move the a over here just because I like keeping the variables positive. Doesn't matter. And then move the 6 over here. So we have one answer where a could be 1. Okay, that's one possible answer. Here, let's distribute this negative. So we have a minus 4 equals negative 3a plus 6. And so moving this a over, I have 4a equals 10, or a is 10/4, which is 5/2. All right, so now when we have variables on the outside, here it's really important to check. We might be able to get away with not checking on the first two because they're just numbers, but here it's kind of important. We could have something called extraneous solutions. So let's check our first value, which is the 1. So we're going to plug 1 in for a in my original equation, and we'll work it out. So I've got negative absolute value negative 3 equals, let's see, 3 minus 6 is negative 3. That's not true, right? 3 doesn't equal negative 3. So therefore, this particular answer is extraneous. That means we got an extra solution that's not really a solution. So that one we have to throw out. Okay, so let's look at our other one. So we've got, we're going to plug in 5/2 in place of a up here. So we've got 5/2 minus 4 equals, let's see, negative 3 times 5/2 plus 6. And so, of course, we have the absolute values around here. This is, we're going back to our original. That's where we plug back in, not into each of the little sides, but to the actual original with the absolute value. So let's see, 5/2 minus 8/2 gives me negative 3/2. Excuse me. So we've got negative 15/2 plus 12/2 gives us, let's see, oops, I have my signs flipped. Silly me. We're looking at this one right here. So I've got 15/2 minus 12/2. That would be what? 3/2 equals 3/2. And that's a check. So this is a equals 5/2. Actually the only solution to this one. Okay, last example. We do need to isolate the absolute value, so we need to deal with this 5. So we're going to divide both sides by 5. So 5w divided by 5 is w. 40 divided by 5 is 8. All right, so now we're basically where we were at the step of, over here. So let's set up our two different equations. So we've got 4w minus 1 is w plus 8, or 4w minus 1 is the opposite of w plus 8. Okay, so let's work out those values. So Let's move the w over. That gives us 3w. Move the 1 over is 9. So w could be 3. Or we've got 4w minus 1 is negative w minus 8. So we've got 5w. Move the negative 1 over. And w is negative 7/5. Now I will tell you that I have checked both of these. They are both valid answers. They both work. Or, I mean, again, you can write it in set notation if you would like to. So negative 7/5, 3, whichever way you would like to. And that basically takes care of our lesson on absolute value equations.